We performed 4 main tests to determine the identities of the drugs provided. Each drug was ground up via mortar and pestle prior to each test so as to maximize surface area to volume ratio, allowing for a much faster and more noticeable reaction. The first reaction is with dilute ferric chloride solution. We reacted the drugs with dilute ferric chloride solution in water and shook the test tubes to identify paracetamol, as paracetamol is the only drug capable of reacting with ferric chloride due to its phenol group. This worked as expected in practice, with only one drug, drug A, reacting during the test. As you can see, a slight color change is observed from yellow to a yellow-green for tablet A, whereas for the other 3 tablets, the solutions remain yellow. Drug A would later be identified as paracetamol. The second test is adding sodium bicarbonate powder to a fresh sample of water-dissolved drugs heated in a water bath. We placed the test tube in the water bath after the carbonate was added to provide a bit of heat, as not too much heat is required. This was a neutralization test to identify aspirin, the only drug with a carboxylic acid group. It would react with sodium bicarbonate to be neutralized, causing effervescence or bubbling. This test also proceeded as expected, with only drug C, later identified as aspirin, reacting to produce a slight bubbling as seen here. The third test was an oxidization test using acidified KMnO4 to differentiate the last 2 drugs, ambroxol and loperamide. This is because ambroxol only has a secondary alcohol group, while loperamide only has a tertiary alcohol group. Thus, KMnO4 will only oxidize the alcohol group on ambroxol. The test mostly proceeded according to plan, barring 2 issues. First, drug C, already identified as aspirin, also produced a slight color change from pink to maroon. This was likely because initially drug C in water was cloudy, hence making the saturation of the purple-pink color lighter. In a retest, we managed to achieve a negative result for tablet C, with the KMnO4 remaining purple, hence tallying with our predictions. Second, tablet B, when reacted with KMnO4, did not yield any color change. After much shaking of the test tube, it turns red, then a dark orange, and then a yellow. However, after a retest, we achieved the prediction of a positive test result for tablet B, where KMnO4 decolorizes. The previous discrepancy could be because as tablet B slowly dissolves in water, the KMnO4 slowly reduces to form manganate 4+ ions, which are orange-brown in color. However, after a while, the orange-brown fades away, implying there's still oxidation till manganate 2+ ions are formed. Lastly, we used the steric ammonium nitrate test, or CAN test, to identify the drugs with alcohol groups so as to provide a positive test for loperamide. For tablet B, it changed from a yellow to a red, implying the presence of an alcohol group. For tablet C, the solution remains yellow, confirming it is aspirin. However, this test resulted in 2 discrepancies. Drug A also reacted with the steric ammonium nitrate. This was unexpected, as we did not think that phenols could also produce a reaction. However, further research proved that this was indeed the case, thus our expected results were incorrect. Phenols can form a dark brown precipitate with steric ammonium nitrate. In addition, tablet D achieved a yellow-brown color and not the usual red as for alcohols subjected to this reaction. After adding a bit more steric ammonium nitrate, there is a hint of red color developed. This is because steric ammonium nitrate is a strong oxidizing agent that is able to oxidize the tertiary alcohol in tablet D and hence achieving a brown color. From our tests, we concluded that drug A was paracetamol, B was ambroxol, C was aspirin, and D was loperamide. This concludes our chemistry video.